Welcome to Amazon Academy. I am Vipul Mehta. कैसे हैं सब लोग? So last time when we met, we finished thermodynamics lecture number 1, and we covered the basic definitions of thermodynamics. Hi Suraj, hi Sayan, RSAS, what are your names? Please write. And we finished how to calculate work done in different cases, right? That was what we covered in the last class. Today we are going to take care of the other two things, which is hi JD, which is the heat Q, hi Dipanshu, as well as the internal energy U, as well as the enthalpy H. Hi Palash. Thermodynamics is the proper use of plus and minus, SG, and a lot more things. Hi DK, hi AT. DK, you are Dipanshu, right? Same DK. Hi everyone. So what we are going to do today is we are going to do a complete postmortem of the first law, and once we do the postmortem of the first law, then basically we are going to do every kind of problem which is related to thermodynamics first law, and this will also be very much useful when we are going to do this the same thing in physics. Okay, so let's start. For people who don't know me, I am Vipul Mehta, BTech IIT Bombay. If you have Physical Chemistry by Wiley Publication, I am the author of that book. And these are some live class best practices. Join the class on time, watch the complete lecture, attend all the classes. In case you miss any class, watch the recording, revise the previous class topics before you come to the next class. Be kind, be polite with your friends, your peers, your teachers. Don't spam here, don't use any kind of uncivilized language. And in case you have any specific academic doubts, then you can use the My Doubts tab, which is kept, if you will see your screen, it is near the chat tab. Okay. If you're watching it on laptop, you can use Chrome or Firefox. If you're watching it on mobile, then you can basically use Android version 6 or above. Please make sure that your internet speed is greater than equal to 5 Mbps. Okay, so all set, all set. Should we start the lecture today? So before starting the lecture, just let me briefly revise what we did in the last class. So we in the last class defined what is system, what is surrounding, what are types of system, what are types of boundaries, what is reversible process, what is irreversible process, what are the different types of irreversible process, right? What are the different types of reversible process, like isobaric, isochoric, isothermal, all those things. And then we calculated work done in all these cases. And what will be the work done? Work done will be nothing but the area under the PV curve. And basically, so this lecture is going to be in English SG. There are going to be some lectures which will be in English also. Okay. So before you start the lecture, you will see that it is written English or English. Okay. So this lecture will be purely in English, but in case you have any doubt, I will again explain it to you. That's not going to be a problem. Okay. Should we start? Should we start the lecture today? So today we are going to cover heat, internal energy, enthalpy, relation between delta H and delta U, summary chart for first law, irreversible adiabatic process, and Carnot cycle. So these are the things which we are going to cover today. Okay. So should we proceed? First, what is heat? So if I ask you, this is one form of energy which is represented by Q. Okay. Now this is the energy which flows due to difference in temperatures. Okay. Now this is an unorganized form of energy. So when I say unorganized form of energy, I will say that yes, there is a temperature difference. If there is a temperature difference, heat will flow. That is the only thing you know about it. So ideally for heat, you just should remember one thing. If I ask you what is specific heat capacity, this is specific heat capacity. So this is equal to heat per unit mole per unit change in temperature. So if I ask you what is specific heat capacity, I will say amount of what I will say about specific heat capacity, I will say amount of heat per unit mole per unit change in temperature. So my volume is on full. I think I don't think there's a problem at my end. I think you should increase the volume at your end. I think my voice is perfectly fine because I can check it. It's perfectly fine. JD, just check it once. So now tell me one thing. It's a constant value for a given substance, yes. For a given substance, yes. Okay, RS. So now my question is, if I take specific heat capacity at constant volume, so this is specific heat capacity at constant volume. So this value will be heat at constant volume upon n dt, yes or no? Now one thing which we will study later is that heat at constant volume is nothing but delta U. So this will be del U by del T because we are keeping volume as constant into 1 by 1. Why? Since I can say heat at constant volume is equal to delta U. This we will prove later. By the end of class I will prove this also. So don't worry. So can I say this? Cv is equal to 1 by n du by dt at constant volume. Now if I ask you, can you tell me what will be Cp? So Cp will be specific heat capacity at constant pressure. So I will say it will be heat at constant pressure upon n dt. Now heat at constant pressure is delta H, which we will cover in a while. So this will be 1 by n, this will be Cp, this will be del H by del T, keeping pressure constant. So I can say since Q at constant pressure is equal to delta H, which we will cover. So net I can say, if you are taking per unit mass, then it will be mc delta T, otherwise it will be nc dt, one and the same thing. No, not C is not equal to mc delta T, that is Q, Rs. Q is equal to mc delta T, not C. Heat capacity, specific heat capacity is Q upon n dt. Okay. So one more thing which we should remember, which will be handy, is this is something which we have covered in the last class. For any ideal gas, what we can say for any ideal gas, I can say that Cp minus Cv is equal to R. Also I know Cp upon Cv is equal to gamma, where gamma is the Poisson's ratio. This we have covered in the last class. So if I combine both of them, can I say that Cv is equal to R upon gamma minus 1? No, we have 2 more classes after this. Okay, HP. HP, your name is Hetav, right? Hetav Pandey. Hi, Hetav. Is it fine now? Shall we proceed? So net what I can say is heat is basically because of difference in temperature, and this is Cp and this is Cv. Ideally, if you ask me how to calculate heat, I will always ask you to find delta U and W, and then you can find heat. This we will cover later in the class today. If I ask you about what is the sign convention, so the sign convention for heat is, it is positive if given to the system, and negative if given by the system. Crash course is for people who are in 12th and droppers batch giving JE this year. Micro course is for other people, okay, especially for class 11th or people who are in 12th presently and want to study in detail about a particular thing. Okay, so for example, if I say 20 kilojoule of heat is given to the system, then the sign will be positive, so the answer will be Q is equal to plus 20. If I say 20 kilojoule of heat is given by the system, then I will say the heat will be minus 20 kilojoule because it is given by the system. For n moles, this is for 1 mole, okay, because it is unit per unit mole, okay. Are we okay here? Shall we proceed? Okay. What is internal energy? So now this is very, very, very important. Okay, so let's write it. What is internal energy U? So if I say internal energy U, it is sum of, so let's say there is a system. This is a system and there are a lot of particles of system. So these are particles of system. These are particles of system and this is system. Okay, so if I ask you what is U, U is sum of kinetic energy of particles of system plus potential energy of particles of system plus if there are some chemical bonds, then chemical bonds, the energy related to those, plus I can say some nuclear forces, so nuclear energy, plus I can say some insignificant forms. So basically sum of all these energies is equal to internal energy U. Sum of all these energies. My question to you is, if all these energies combine together, okay, why can we find the absolute value of U? Can we find the what is the exact value of U? So see, kinetic energy is a function of temperature. So I can find the exact value of kinetic energy. Potential energy is a function of pressure, volume and temperature. Now potential energy, even in physics you have studied, it's a reference value. So if you take at ground is equal to 0, only then at high touch it is mgh. So it is always a reference value. You cannot find the absolute value of potential energy. So I cannot find this value. Chemical bonds, yes, I can find. Nuclear energy, difficult to find. This insignificant, even if we neglect it, we cannot find the absolute value of U. Okay, so can I write that we cannot find the absolute value of U? Is this fine? Hi AD. Is this okay with everyone? Because we cannot find the absolute value of this or this. Now, if I ask you to say, okay, let's say what is delta U. So I can say delta U will be delta of kinetic energy plus delta of potential energy plus delta of chemical bonds plus delta of nuclear energy plus delta of insignificant forms. Yes or no? It's per mole. You can also take it per gram SC. Depends on what is given to you. But it is per unit mass or per unit mole. Okay? Now listen to me carefully. For example, if there was C single bond C, the value of C single bond C will remain the same before and after the reaction. So this change will be nothing. Since it is not a nuclear reaction, it's only a chemical reaction, the nucleus will remain the same before and after. So this will be 0. Insignificant is small. So basically I am saying it is d of d. D of dx will be even further smaller. So again I can say neglected. So can I say that delta U is delta of kinetic energy plus delta of potential energy? Yes or no? So now this is something which we can calculate. Okay. So when I say this is something which we can calculate, what do I mean by this? Let's see. Is everything fine till now? Shall we proceed? Shall we proceed, all of you? This is easy. Perfect. Okay. So now what we should do is, I will say delta U is equal to delta of kinetic energy plus delta of potential energy, right? Now this is a function of temperature and this is a function of pressure, volume and temperature. Yes or no? So if I mix both of them, can I say delta U is a function of pressure, volume and temperature? Yes or no? Because it is a function of T here and this is a function of PVT. So net I can say delta U is a function of P, V and T. Now there is one more thing which I will tell you. Since there exists a equation or an equation of state for solids or liquids or gases. So what do I mean that equation of state? For example, PV equal to nRT is a equation of state. So if there is an equation of state, I can express P in terms of Vt, or I can express V in terms of P and T, or I can express T in terms of P and V. Yes or no? Because you will have something like PV equal to nRT for solids also, for liquids also and for gases also. The equations will be different. So can I say, because of this, I can express delta U or du as a function of Pt or as a function of PV or as a function of Vt? Yes or no? So let's say I choose this one. So I can say delta U is a function of V and T. Simple enough. Now tell me one thing. I can say U is a state function. This is something which we have covered. So if I say it is a cycle like this, okay, can I say the value of U in this whole cycle? What will be the cyclic integral of U? I can say cyclic integral of du will be 0 since it is a state function. Yes or no? Now one thing which you will study in maths is, if there is a function, let's say fxy, so I can say dfxy is equal to 0. If this is true, that is a cyclic function, okay? So this df can be expressed as del f by del x keeping y constant into dx plus del f by del y keeping x constant into dy. So if we have anything whose cyclic integral is 0, I think SU, we have covered all these questions. If you want to appear for JEE Mains 2021, I have covered this chapter in the crash course, okay? So obviously you will get question from this chapter, why not? It is a chapter right in the syllabus. You will get a question from this chapter in physics as well as chemistry, okay? So listen to me carefully now. What do you mean by this? So for example, if I say now any cyclic integral mathematically whose cyclic integral is 0, so for example integral dfxy is equal to 0, it can be expressed like this. So can you tell me now, according to this maths, can I say something like this? Can I express du as del u, because I am expressing it as a function of Vt, I can express it as del u by del V at constant temperature into dV plus del u by del T at constant volume into dt? Yes or no? Using the same concept. Yes or no? Because it is also a state function, so cyclic integral of this will be 0. Now tell me one thing. Can I say del u by del T at constant volume? I am talking about this term, del u by del T at constant volume. Can you tell me what is del u by del T at constant volume from this equation? Del u by del T at constant volume is equal to N into Cv. Yes or no? Yes or no? So if I substitute the value of del u by del T at constant volume, I can say du is equal to, I'll write it again, du is equal to del u by del v at constant temperature dv plus n cv dt. So this is the fundamental equation of du. Everything is clear now? So this is always true. This is clear to all of you? So let me write it for case 1. Case 1, if we have an ideal gas. I'm writing what was the expression. The expression was du is equal to del u by del v at constant temperature into dv plus ncv dt. Okay, this is the fundamental equation. This is clear to everyone? Suppose I say if it is an ideal gas, I will start with the first step. Delta u is delta of kinetic energy plus delta of potential energy. I know this is a function of temperature. Since for an ideal gas there is no force of attraction or no repulsion, can I say this will be 0 because there will be no potential energy if there is no attraction, no repulsion between particles? Yes or no? So can I say du in this case will just be a function of temperature? Yes or no? Because the second term will be 0. If that is the case, I write this equation du is equal to del u by del v at constant temperature into dv plus ncv dt, right? Can I say this is a function of temperature, and now since I'm keeping temperature as constant, so for example let's say du is equal to 2 into capital T, so it's a function of temperature. So if I keep temperature as constant and I differentiate it, this will be 0 because it will be a constant only. So if I say 2t and t is constant, so 2t will also be constant, so differentiation of that will be 0 because differentiation of a constant value is 0. Yes or no? This is clear to everyone? So can I say that du is equal to n into cv into dt? Now for every ideal gas, this is always true. Ideal gas always. So this is what you study in your textbooks. They don't tell you the exact derivation. Directly write du is equal to ncv dt. But I think now it is clear to all of you. Yes or no? This is clear to all of you, yes or no? If in case I give you an isochoric process, perfect, great. If I give you an isochoric process, then I can say dv is equal to 0. So if dv is equal to 0, first term is 0. So I can say in that case also du is equal to ncv dt. Perfect. If I give you case 3, something like a solid or a liquid, the solid or liquid, the expansion will be nearly close to 0. So I will say if expansion or contraction is nearly close to 0, I can say du approximately is ncv dt. Yes or no? And case 4, if you are given a real gas, so in that case then you have to say du is equal to del u by del v at constant temperature into dv plus ncv dt. There is no assumption you can make. So 99.99% cases you will be given an ideal gas. So can you tell me, hi MK, hi AB, can you tell me one thing? If it is an ideal gas, what will be the value of du? It will always be ncv dt. Hi Mithilesh. Simple. Is this clear to all of you? So what we need to remember is for an ideal gas, du is ncv dt. Clear? Yes or no? Hi Shiva. Hi. See, I request all of you to make sure of two things. A, you actively participate in the class. So when I ask you a question, answer, and B, attend all the classes. Because people who have attended last lecture will attend this lecture, they will understand more because everything is connected in thermodynamics. So for a given chapter, attend all the lectures. So don't, it should not be the case that in case you are coming today, come to the next lecture also. Only then you will be able to understand everything properly. Okay, shall we proceed? Hi Solomon, hi. Can you tell me what is enthalpy? So enthalpy is defined as H, which is defined as U plus P into V. Okay. Can you tell me one thing? If the absolute value of U cannot be calculated, because we have seen that U cannot be calculated, absolute value. So can I say the absolute value of H cannot be calculated? Yes or no? Simple enough. Because the absolute value of U cannot be calculated, so the absolute value of H also cannot be calculated. Can you tell me one more thing? If I say dH, I can say it will be du plus d of PV. Now this we have done is a function of pressure, volume and temperature, all three. This is a function of pressure and volume. So can I say dH will be a function of pressure, volume and temperature? Yes or no? So I write dH is a function of P, V and T. Now since there exists an equation of state for solid, liquid or gas, can I say I can write dH as a function of PV or as a function of VT or as a function of PT? What do you mean by equation of state? For example, PV equal to nRT is an equation of state. So I can express P in terms of V and T, or I can express V in terms of P and T, or I can express T in terms of P and V. So basically I only need two variables to find this value. Yes or no? Exactly the same thing which we had done previously for delta U. So can I say this is a function of PT? I can choose this one. Now again I know, hi SH, I think you are late SH. Now I can say that H is a state function. So if H is a state function, can you tell me what is the cyclic integral of dH? Cyclic integral of dH will be 0 because it is like displacement or state function. So the overall value addition across the cycle will be 0. Yes or no? Simple. GY, nothing to be afraid of, right? In case you have mains now, attend the crash course. Okay. Now if this cyclic integral is 0, can you tell me it is exactly like a mathematical function dfxy is equal to 0, and I can express this as df is equal to del f by del x at constant y dx plus del f by del y at constant x into dy. Yes or no? Yes, GY. Yes. Can you tell me one thing? If I say this is a function of Vt, I can say dH is a function of P and T. This is exactly like what we have done for du. So can you tell me what will be the case in this case? I can say dH can be expressed as del H by del P at constant temperature into dP plus del H by del T at constant pressure into dt. Yes or no? Is this fine with you, all of you? This is exactly the same like the one we did in the section before this. SH, NS, MV, AS, AB. This is clear to all of you? Say yes. Clear. Perfect. Perfect. Tell me one thing. I will write this again. I will say dH is equal to del H by del P at constant temperature dP plus del H by del T at constant pressure into dt. We can take anyone. I am taking so that I get a favorable answer. GY, you should attend the last class. I have taught that. Okay, attend the last, see the recording of the last class, GY. Can you tell me what is del H by del T at constant pressure? Can you tell me the value of this? Can I say del H by del T at constant pressure is equal to N into Cp? Yes or no? Yes? NCP, yes, PR, perfect. So if I substitute this value here, can I say this value is nothing but NCP? So can I say dH is equal to del H by del P at constant temperature dP plus NCP dt. So this is the fundamental equation of dH. Now let's take case 1 for an ideal gas. Can you tell me what will be the case for ideal gas? I can say dH is equal to du plus d of PV. This I know for ideal gas is a function of temperature. We just did it. For an ideal gas, du is a function of temperature. Yes or no? So this is a function of temperature. What is PV? PV is equal to nRT. So this whole thing is also a function of temperature. So can I say in this case dH is a function of temperature? Yes or no? So if I substitute it here, I can say dH is equal to del H by del P at constant temperature dP plus NCP dt. Now this is a function of temperature. Let's say it is 2T. PV equal to nRT, you don't know NS, seriously. For an ideal gas, PV is equal to nRT, right? This is something which you don't know, NS. Is that what you are trying to say? This is clear? This is clear? So now tell me one thing. If dH is a function of temperature and I am keeping temperature as constant, so this whole thing will be a constant, so this will be 0. So can I say dH is equal to NCP dt for an ideal gas always? So this will be asked to you in 99.99% cases. That is the reason in most of the books they directly write dH is equal to NCP dt. But now I have told you how do we get it. Okay. Suppose I give you isobaric process. So if you are given an isobaric process, I know that dP is equal to 0. So if dP is equal to 0, I know that dH is equal to NCP dt. Simple enough. This is clear, everyone? Okay. So if I give you a real gas, that will be case 3. So in real gas, I can do nothing. I have to use this equation. So for real gas, if the process is isothermal, dH is not equal to 0. Only for ideal gas, if process is isothermal, dH is equal to 0. Because if dt is 0, this term will be 0, but not this. This is clear to all of you? Simple enough. Now at times they will give you an equation like for example, I give you AA plus BB gives CC plus DD, and all of them are gases, let's say. Okay, so if I ask you what is the value of delta H, suppose delta U is given to you and temperature is given to you. So case 1, all gases, which one? This one? Which one, JD? JD, which one? JD, which one? The previous slide. dH is equal to NCP dt for an ideal gas. If it is an isobaric process, this term is equal to 0. And if it is a real gas, you cannot do anything about it. That is the only thing I said. So if I say dt is equal to 0, this term is 0. So for an isothermal process, dH is equal to 0 for an ideal gas. But for an isothermal process, dH for a real gas is not 0, because only this term will be 0, not this term. Now this is clear to all of you? So if all gases are ideal gases, suppose this is the case. Yes, we will do questions. Yes. So all of you wait till the end of class. We will do a lot of questions. Let's first understand the concepts. If you will see, what I am doing is I am doing post-mortem of W, Q and delta U and delta H. Once we do the post-mortem of these, we can do all the questions. I will explain it to you. Okay. If all gases are ideal gas, I can say delta U is equal to delta H is equal to delta U plus delta of PV. Now this PV is equal to nRT. Now R and T are constant. So this will be N of products minus N of reactants because it is delta. So this will be nothing but delta H is equal to delta U plus RT. This will be moles of C plus moles of D minus moles of A minus moles of B. Now moles of C is equal to C, moles of D is equal to D, moles of A is equal to A, moles of B is equal to B. So I will say it is delta Ng. What is delta Ng? Delta Ng is change in gaseous moles. What do you mean by change in gaseous moles? Change in gaseous moles is gaseous moles of products, which is C plus D, minus gaseous moles of reactants, which is A plus B. So I can say delta H is equal to delta U plus delta Ng into RT. So for example, just to give you an idea, if I give you C solid plus half O2 gas gives CO2 gas, assume gives CO gas. If all gases are ideal, can you tell me the relation between delta H and delta U? So what you will say delta Ng is equal to 1 because it is gas, minus you will say this is solid. So solid is 0 plus half. So this is half. So I will say delta H is equal to delta U plus half into R into T. Simple enough. So in case all the gases are given to you as an ideal gas in an equation, and you need to find the relation between delta H and delta U, you can use this equation. Simple enough? Yes or no? Yes or no? Perfect. Shall we proceed? Suppose I give you a question in which, case 2, the gases are not ideal. So if the gases are not ideal, in that case I will write delta H is equal to delta U plus delta PV. Now I cannot write PV is equal to nRT because the gases are not ideal. So I will simply say delta H is equal to delta U plus P2V2 minus P1V1, where P2V2 is the final pressure and final volume, P1V1 is the final initial pressure and initial volume. Let's do a question on the basis of this. Suppose I give you an equation CO2 gas, I will say 1 atm 1 liter changes to CO2 gas 2 atm 2 liter. You are given delta U is equal to 2 kilojoule per mole. You are given temperature as 298 Kelvin. Okay. You have to find what is the value of delta H. Case A, all gases are ideal. So if all gases are ideal, I can say delta H is equal to delta U plus delta Ng into R into T. Now delta Ng in this case is 0. Since delta Ng is equal to 1 minus 1 is equal to 0. So the first case, the answer will be 2 kilojoule per mole. Simple enough. If I give you the second question, all gases are real. Can you tell me what will be the answer? So in this case, the answer will be delta H is equal to delta U plus P2V2 liter atmosphere minus P1V1 liter atmosphere. 1 liter atmosphere approximately is equal to 100 joules. So if I give you the answer in kilojoule, it will be 10 to the power of minus 3 kilojoules. This is the value as 2. So basically 4 minus 2 is 3. So this will be 2 plus 300. So 3 into 10 to the power of minus 1. So this will be 2.3 kilojoule per mole. Simple enough. Yes or no? Why? I am using one conversion. 1 liter atmosphere is approximately equal to 100 joules. Simple. So this is clear to all of you now. So here I cannot use delta H is equal to delta U plus delta Ng because they are not ideal gases now. I hope this is clear to all of you. Perfect. Yeah, exactly. It is 101.3. Okay, GY. I know it is 101.3. That's the reason I have written approximately. Convert it into liter atmosphere to joules. Okay, AP. That is something you can do at home. 1 atm is how much in pascals? 10 to the power of 5. So bar liter is approximately equal to atm liter. It's approximately the same GY. Let's not fight about it. It's very simple, right? Shall we proceed? Now this is something which is super important. Now let's put all of these things together. Okay. Let me say that we are taking all gases are ideal. Okay. All gases are ideal gases. So let's say this is case. Let's say this is delta U. Let's say this is delta H. Let's say this is W, and let's say this is Q. Now let's combine everything what we have learnt. Okay. Okay, let's start. First case. Irreversible expansion of an ideal gas against constant external pressure P external. Tell me what will be the work done. This is something which we have done. Minus P external into delta V. If it is an ideal gas, this value is NCV delta T. This value is NCP delta T. Yes or no? So what will be Q? Q is nothing but delta U minus W by first law. So can I say Q is equal to NCV delta T plus P external into delta V? Yes or no? Yes or no? This is simple enough. Okay, let's change it a bit. If I say reversible isobaric expansion. Okay, starting with delta U, it's an ideal gas NCV delta T. Ideal gas NCP delta T. Yes or no? What is work? Minus P into delta V. Yes or no? This is something which we did in the last class. Can you tell me what will be Q? It will be, what will be the value of Q? So Q will be N CV delta T plus P delta V. Can I write it as N CV delta T plus NR delta T? Can I say it is nothing but N Cv plus R delta T? Can I say it is nothing but N Cp delta T? Can I say it is nothing but delta H? So can I say heat at constant pressure is equal to delta H? Yes or no? I told you in the beginning of class that heat at constant pressure is delta H. Now is it clear to all of you? Yes or no? I have derived it for you. Yes or no? Simple enough. Okay, let's take the third case. Suppose I say I have reversible isochoric process. So if it is isochoric, work is 0. It is an ideal gas, so this is NCV delta T, this is NCP delta T. This heat will now become heat at constant volume, which will be nothing but delta U. Yes or no? Because work is 0. So can I say that heat at constant volume is equal to delta U? This is what I have told you before. Now you know how. Yes or no? Suppose I give you reversible isothermal process. Okay, if it is isothermal, this is 0 for an ideal gas, this is 0 for an ideal gas because delta T is 0. What is work? This is something which we did, minus nRT ln V2 by V1. So Q will be equal to minus W, so this will be nRT ln V2 by V1. Yes or no? Simple enough. Again, pretty straightforward. Yes or no? Say something, all of you. Don't sleep. This is clear to all of you. This is just a revision of whatever we have done so far. Clear? Perfect. Suppose I give you reversible adiabatic. So if it is reversible adiabatic, this value is NCV delta T. Ideal gas, this value NCP delta T. Perfect. If it is adiabatic, Q is 0. So can I say W is equal to delta U because Q is 0 is equal to NCV delta T. We use a complete page to derive this. Now we can derive this in one line. Yes or no? I told you in the last class that we can derive the work in one line also. It can be done. It is clear to all of you now. Suppose I say free expansion, which is adiabatic in nature. So if I say adiabatic free expansion means work is equal to 0. Adiabatic means Q is equal to 0. That means delta U is equal to 0 because both of them are 0. So I can say if delta U is 0, ideal gas NCV delta T is 0. So delta T is 0, so delta H also is 0. So everything is 0. Yes or no? Suppose I tell you isothermal free expansion for an ideal gas. So isothermal delta U is 0, isothermal delta H is 0, free expansion work is 0. Therefore, if delta U and work is 0, can I say Q is equal to 0? Everything is 0. Yes or no? Is this clear to all of you? So this is one chart basically which is the summary for first law. If you are able to get a grip over this, I think you will be able to solve all the questions. That is the reason we first did a postmortem of W, then we did the postmortem of delta U and delta H. Q can be found because you can calculate delta U and W for everything. So Q is nothing but delta U minus W. Adiabatic is when heat is equal to 0. I covered it in the last class PR. Please see the recording. Now there is one important question. Suppose I tell you, calculate work done in irreversible adiabatic process, okay, against constant external pressure is equal to P external, initial pressure of the gas is equal to P1, final pressure of the gas is equal to P2, initial temperature of the gas is equal to T1, and you are given gamma is equal to Poisson's ratio. Suppose this is the question which is given to you. You have to calculate the work done. So remember one thing, I am writing a note here. Note: if irreversible adiabatic, we cannot use PV to the power of gamma is equal to constant. This is something we cannot use. Let's say you are given for an ideal gas. You are given an ideal gas. So what we will do in this question is solution. Now since this is adiabatic, I can say work plus Q is equal to delta U. This will be 0 because it is adiabatic. Can I say work is nothing but N into CV into, or I can say minus P external, and since P external is constant, that will be minus P external delta V, and this will be N into CV into delta T. Yes or no? Yes or no? So can I say it is nothing but minus P external V2 minus V1 is equal to N, CV is R upon gamma minus 1, T2 minus T1? Yes or no? Now can I write minus P external, this is volume of the gas, so can I write it as nR T2 by P2 minus nR T1 by P1 is equal to nR upon gamma minus 1 T2 minus T1. So this nR will get cancelled out. Now in this complete equation, what all are given to you? P external is given to you, P2 is given to you, P1 is given to you, T1 is given to you, gamma is given to you, T1 is given to you. Only one equation, one variable. Can you get the value of T2? Once you get the value of T2, what will be work done? Work will be min into CV into T2 minus T1, which you can calculate because this value will be nothing but R upon gamma minus 1. Let's say number of moles given to you as N. So can you calculate work done now? So remember one thing, irreversible adiabatic process is an important process because in this case you cannot find the pressure or temperature or volume using the equation PV is PV to the power of gamma is equal to constant. You have to use the first law of thermodynamics. Simple enough. This is clear to all of you. Is this clear to all of you? Yes or no? Say something, guys. Is this clear to all of you? Perfect. AS says yes. Other people? Okay. Can you do one question for me now? So this is Carnot cycle. I will tell you a hint. No, what is not clear, A? What is not clear to you? A, what is the exact doubt? Please tell me. See, what I am saying is, if I want to find the temperature for an irreversible process and it is adiabatic, I cannot use PV to the power of gamma is equal to constant. This is something I cannot use. So if I have to find the final temperature, I can say work is equal to this. The only thing is I know this, I know this, I know this, but this is something I don't know. So I have to calculate the value of T2, and this value of T2 cannot be found using this expression now, because it is irreversible. So for an irreversible adiabatic process, always use the first law. This is the first law. This is what I am trying to communicate. A. Are we clear now? Shall we proceed? Okay, so there is a question for all of you. This is a graph, okay? This is the graph. This is P, this is V. Let's say this is 1, this is 2. So 1 to 2 is isothermal process. The temperature here is T1, okay? Pressure at 1 is P1 V1, pressure and volume. At 2 is P2 V2. Simple. 2 to 3 is adiabatic process. At 3 the pressure is P3, volume is V3. 3 to 4 is again isothermal, but this time it will be compression. This pressure is P4, this volume is V4, and then again you are going back to point 1. This is clear? Now my question to all of you, listen to me carefully. Listen to me carefully now. PV curve is given to you. You are given that it is an ideal gas. Okay. So for let's say the temperature is T2, I can definitely say T1 will be greater than T2 because there are two isotherms. Yes or no? Simple enough. The one which is at top, this is isotherm, this is also isotherm. So as you go higher, this T is going to increase. So T1 is greater than T2. Can I also write for 1 to 2, I can say P1 V1 is equal to P2 V2. That is equation 1. Then I can say P2 V2 to the power of gamma is equal to P3 V3 to the power of gamma, because it is a reversible process. All the cyclic processes are reversible. Okay. Then I can say P3 V3 is equal to P4 V4. And then I can say P4 V4 to the power of gamma is equal to P1 V1 to the power of gamma. I can say these things, yes or no? So if I combine these two, and I multiply them, can I say P1 into P3 into V1 into V3, or I can just divide them, that's a better option. If I divide them, can I say P1 by P3 into V1 by V3 is equal to P2 by P4 into V2 by V4? Yes or no? Can I say this if I combine this equation and this equation? And if I combine these equations, can I say P2 by P4 upon V2 to the power of gamma, V4 to the power of gamma is equal to P3? Let me just reverse it. I will write it here. I will say P2 by P4 into V2 by V4 gamma is equal to P3 by P1, and this will be V3 by V1. Have I done something wrong? This is fine, this is also fine, so this should be some correction, right? V3, so this will be left with V1, P4 V1 gamma, P1 V1, P2 V2 is P3 V3. Okay, I think we are pretty much sorted, right? Can you tell me that if you use all these equations, I will tell you a homework to be done. Okay, so in fact, this is also a strong hint. Let me just write these equations. Okay, this is one hint which you have. Okay, this is one hint which you have. Suppose. So, can you tell me one thing, that if this is one hint, can you tell me now what will be the work done from 1 to 2? If I take 1 to 2, what is the work done from 1 to 2? Can you tell me? It is isothermal process. So can I say it is minus n into R into T1 ln V2 by V1? Yes or no? Yes or no? What will be the value of delta U from 1 to 2? It is isothermal, so this will be 0. So Q12 will be minus W12, which will be nRT1 ln V2 by V1. Yes or no? Clear? This is clear? Can you tell me if I go from 2 to 3? So what will be the value of Q from 2 to 3? It is adiabatic, so Q from 2 to 3 is 0. What will be W from 2 to 3? It will be N into Cv into delta T. Delta T will be T2 minus T1. Yes or no? Okay. If I say minus nR T1 ln V2 by V1, V2 is greater than V1. So this term is coming out to be negative. So definitely this term will be positive. So I can say that this term is positive. So Q1 is entering into the system. Can I say this is Q1 is equal to Q in because heat is positive? Yes or no? Because work is negative because it is expansion. Similarly, T2 will be less than T1. So can I say that this term is going to be negative? Yes or no? Obviously it is expansion, so work is done by the gas. If I go from 3 to 4, can you tell me what will be the value of W34? That will be minus nRT ln V4 by V3. So V4 is less than V3 because it is compression. So I will say this value comes out to be positive. If I ask you what is delta U from 3 to 4, it will be 0. If I ask you what is Q from 3 to 4, it will be minus W from 3 to 4. So I can say it is minus plus, so it will become nRT2 ln V4 by V3. Can I say that this term will be negative? So can I say that heat is leaving the system? Let's call it as Q2. So can I say Q2 is equal to Q out because it is negative? So it is leaving the system. Yes or no? If I take 4 to 1, can you tell me what is happening from 4 to 1? W4 to 1 is NCV T2, which is T1, T final minus T initial. And what is Q4 to 1? It is 0. Yes or no? Is this clear to you? So I am just applying what we have done in the summary chart. I am just applying it here. If I add all the work, can you tell me what is W total? So W total is W12 plus W23 plus W34 plus W41. What is Q total? It is equal to Q1 plus 0 minus Q2 plus 0. Because why minus? I am just using the magnitude also because I know this is negative, right? And this I am calling as Q1, this is Q2. So Q2 is the heat leaving the system. So this will be Q sink. Now if this is a reversible engine, can you tell me what is delta U total? I can say delta U total is equal to 0. So I can say W total plus Q total is equal to 0. So I can say minus W total is equal to Q total. Now what is minus of work done? Work done by the gas. So can I say it is work done by the gas? What is Q total? Heat in minus heat out. So can I say it is Q1 minus Q2? Yes or no? So if I ask you what is efficiency of the engine, what is efficiency eta of anything? What is efficiency? Efficiency is output divided by input into 100. Yes or no? Can I say efficiency is output divided by input into 100? Yes or no? What is the output of any engine? What is the output? Output is nothing but work done by the gas. What is input? The heat given. What is heat given? Q in or Q1. So can I say efficiency is nothing but Q1 minus Q2 upon Q1 into 100? So can I say efficiency is nothing but 1 minus Q2 by Q1? Yes or no? Now for this reversible cycle, if I say what is Q1, Q1 is nRT ln V2 by V1. So I will say magnitude of Q12 is nRT ln T1 ln V2 by V1, right? If I ask you what is the magnitude of, this value V4 by V3, so I can say one more thing, that V4 by V3 will be approximately V2 by V1 by these equations. So if I say I divide Q2 by Q1, I will be left with nR T2 ln V2 by V1. This will be nR T1, sorry, this is V4 by V3 ln V2 by V1, right? What will happen is, if I'm just taking the magnitude, this cancels out and this will also cancel out. So your homework is to figure out why will this cancel out. This will cancel out because of these equations. So you will get V2 by V1 as V4 by V3. You will get it using these equations. Okay. So can I say for a reversible cycle, efficiency, I will just write it on the next page. I will say efficiency is 1 minus Q2 by Q1, and for a reversible cycle like this, efficiency is 1 minus T2 by T1, because Q2 by Q1 is T2 by T1. So now tell me one thing, T2 is always less than T1. So therefore efficiency will always be less than 100%. Yes or no? So I can say multiply it by 100, or I can multiply this by 100. That's one and the same thing, right? So efficiency is always less than 100. So when I say efficiency is always less than 100, COP, what do you mean by COP? What do you mean by COP? RK? That is not required. Not required. Okay. That might be used in physics. It is not required in chemistry. Okay. So understand one thing now. Listen to me carefully. Efficiency of no engine can be 100%. So basically what I can say is, if there is a heat given to the system, there will always be a loss in the form of Q2 or Q sink. And that was what the second law was according to Carnot cycle. Now can anyone tell me what was the outcome of this equation? The outcome of this equation was a phenomenal outcome. I will tell you what. Can I write 1 minus T2 by T1 as 1 minus Q2 by Q1? Can I write like this? I can cancel this. I can cancel this. So can I write T2 by T1 is equal to Q2 by Q1? Can I write this as Q1 by T1 minus Q2 by T2 is equal to 0? Yes or no? Can I write this as plus q1 by t1 plus 0 plus minus q2 by t2 plus 0 is equal to 0? Yes or no? Can I write it like this? Yes or no? Now just look at the cycle. This is P, this is V. Okay, the heat here is plus q1, the heat here is 0, the heat here is minus q2, and it is 0 here. This is temperature T1, this is temperature T2. Can you tell me one thing? Can I say that this is nothing but integral or cyclic integral of dq in a reversible process by t, and that is equal to 0? Let's check. What is integral dq reversible by t from this point to this point? So temperature is constant, so T will come out as T1. Integral dq will become plus q. Yes or no? So I will get this term. What is integral dq reversible by t from this point to this point? So I can say q is equal to 0, so it will be 0 by t, so I get 0. What is integral dq reversible by t from this point to this point? I can say t will be coming out as constant as t2, which is here, and dq will become minus q2, so this will be this. And here q is equal to 0, so from this point to this point it will be 0. Yes or no? So can I say that if the cyclic integral of this term is 0, I can say that this term is a state function? Yes or no? And this is defined as entropy of the system. So basically you get delta S system is equal to dq reversible by t. So this was the first time we were able to derive entropy S. So this is true always. So whatever the process is, delta S system will always be dq reversible by t. So in the next class, when we are going to study about entropy, then we will understand that this is useful. Okay? Are we clear about this? All of you? So let's do some questions now. Okay? All of you are ready? Should we start? Okay. First question, more than one correct. Which of the following is correct? Write your answers and your name after your answer. Your time starts now. Now this is very simple for all of you. Write your answers and your name after the answer. Quickly. ACD. Aman is saying your answer is ACD. Okay. Aman is saying ACD. Solomon is saying A and B. Okay. Anyone else? A and D. Arish is saying A and D. Varsha ACD. A and C. Solomon A and C. Yes. A and C are the right answers. C, CP, so it will be delta H, not delta U. So this cannot be there. Delta H by delta T at constant pressure, because it is CP. So this cannot be true. CV has to be delta U. So this cannot be true. Okay. Okay, Omkar. All of you, please pay attention. Nayati, A and C. Yes, Nayati, you are right. Dipanshu, no, B is not correct. If it is CV, it has to be del U by del T, not del H. Okay. Let's proceed. Which of the following statement is or are correct? This is again more than one correct. Tell me your answer now. Delta U is equal to 0 for all isothermal process. It is delta U is equal to 0 for ideal gas, only for isothermal process. Delta U is NCV dt for isochoric process. Delta U is not equal to NCV dt for all isochoric process. Your time starts now. Yes, sir. What will be the answer for this question? So this is based solely on derivation. So what is the equation of du? B and C says Varsha. This is the fundamental equation. So delta U is equal to 0 for all isothermal? No. Only for ideal gases. So this cannot be correct. This is correct. This is correct. This cannot be correct. Simple. B and C is the right answer. Omkar, Nayati, Varsha, good job. Next question. For adiabatic free expansion, this is again more than one correct. An ideal gas is given to you. Which of the following is 0? We just did it in the summary chart. Adiabatic free expansion. Quickly, tell me your answers, guys. B, more than one correct. PR, more than one correct. PR is Solomon. AK says all. AK is Varsha. Varsha says all. Solomon says all. Aman says BD. AS says all. All is the right answer. Very good. Perfect. See, if it is adiabatic, Q is 0. If it is free expansion, work is 0. If both of them are 0, then delta U is 0. If delta U is 0, then NCV dt is 0. If dt is 0, then I can say dH is equal to NCP dt. This will be 0. Yes or no? So all options. Omkar. Right answer is all. ABCD is the right answer. Perfect. Can you do this question for me? I have given 1 liter atmosphere as 101.3 joules. Ideal gas expands against constant external pressure of 1 atm from a volume of 10 liter to 20 liter and absorbs 10 kilojoule of energy from the surroundings. What is the change in internal energy? Your time starts now. Tell me the answer to this question. A, B, C or D? Answer is B according to DK. Aman says B. Okay. Aman says B. Other guys? What is the answer to this question? AP says B. Okay. So delta U is equal to W plus Q, right? Now I can say that the absorbs, so basically this will be plus 10 into 10 to the power of 3 joules, and this will be minus P into 20 minus 10 into liter atmosphere, so 101.3. So this will come out to be 8.98 into joules. Simple enough. B is the right answer. Good job, guys. Okay, can you solve this question for me? 2 moles of an ideal gas is heated at a constant pressure. This is given to you as homework. This is tricky, okay, and this is more than one correct. So do you want me to give you a hint or you will try on your own? You want me to give you a hint or you will try it on your own? You want a hint for this or you will try? Okay, we will discuss it in the next class then. Try it once, okay? Tell me your answer. Solve this question for me. For an ideal gas, the specific heat capacity or the heat capacity hint, NCV dt is the hint. Now try and think about it, AP. Can you solve this question for me now? This is using some of the things which we learned from the last class also. So you have an ideal diatomic gas, gamma is given to you as 1.40. The heat capacity C is the question which is asked to you. Your time starts now. It's a very, very good question. I'm giving you 3 minutes, 2 minutes. Tell me your answers, guys. Write your name. Tell me the answer to this question quickly. C. DK is saying the answer is C. Let's see. Now there is a flood of answers which says C. Okay. RA is saying option D, data insufficient. Okay, let's see. Okay, let me do this for you. AK is saying the answer is A. Okay, let's see. If I say this is PV to the power of X, so this is a polytropic process. So what is work? NR upon X minus 1 into delta T. This is something which we derived in the last class. What is delta U? NCV delta T. What is CV? NR upon gamma minus 1. So what is Q? Q is NC delta T, which is the heat capacity. So if I use first law, I can say Q plus W is equal to delta U. So I can say C is equal to R upon gamma minus 1 minus R upon X minus 1. What is gamma? 1.40. So this will be R upon 0.4. What is X? X is minus 3. So this will be minus 4. So I multiply 10 on both the sides. Right? So I multiply this and this by 10. So I get minus and minus as plus. So I get 11R by 4. So A is the right answer. It's a very good question. Now it is clear to all of you. So this is something which we derived in the last class. If you remember, I did a whole derivation on this. This is something which we did today. This is something which can be derived from first law. So now you can solve the question. So basically this is something which we derived in the last class, AP. So X is minus 3. So basically the answer is NR upon minus 3 minus 1 into delta T. Heat is equal to specific heat capacity. So heat capacity is C. So C into N into delta T is heat. Delta U is NCV delta T, and we derived that CV is equal to R upon gamma minus 1. Because Cp minus Cv is equal to R and Cp by Cv is equal to gamma. You substitute these values, N into delta T will get cancelled out. So this will be the remaining answer. And I just substituted the values then. Okay. This is again a brilliant question. This we will do in the next class. So I am giving you a hint. It is a brilliant question because it is very simple. At the same time, it is based somewhat on the concept like this only. So I'm giving you a hint. If you are able to understand question number 6 properly, you will be able to do this question also. So now try solving it. If it is an ideal monoatomic gas, what will be the value of gamma? What is the value of gamma for an ideal monoatomic gas? 3 by 2R. You can write it as 1.66. Okay. This is also fine. Okay. Solve this question quickly. Efficiency of Carnot cycle is 75%. What will be Q sink if Qn is equal to 300 joules? Your time starts now. What is the answer to this question? Quickly, guys. A, B, C, or D? Write the answer, write your name after this. D. Okay. AP says D. AK, what is your answer? RA, what is your answer? DK, what is your answer? Ashish says D. AS says B. PR says B. So Solomon says B. Hetav says B. RA says A. So what is efficiency? Efficiency is 1 minus Q2 by Q1. That is 1 minus Q sink, the heat which goes out, upon Q1 is 300. So basically this into 100. Now this is given to you as 75%. So I can say 0.75 is equal to 1 minus Q sink by 300. So I can say Q sink by 300 is equal to 0.25. So I can say Q sink is equal to 75 joules. B is the answer. Simple enough, guys. Not difficult, right? Solve this question for me and tell me the answer. I'm giving you that 1 liter atmosphere is 101.3 joule. Okay, and your time starts now. What is the answer? Ashish, Hetav, Solomon, RA, AS, tell me the answer to this question. MS is saying the answer is B. Okay. MS is saying that the answer is B. PR is saying that the answer is B. PR is Solomon. Hi Solomon. Heta, what about you? AP is saying, AP is Ashish. So Ashish is saying B. Okay, Ashish. Heta? Varsha, AK is saying B. So Varsha is saying B. you will to go with B. B is the right answer. So basically this is P1, this is V1, this is P2, this is V2. Okay, so the question is basically you have been asked that if it is a non-ideal gas. So if it is non-ideal gas, I can say delta H is delta U plus P2V2 minus P1V1. You cannot use delta NGRT, so this will not be the answer for sure. So I can say delta H is delta U, which is 2 kilojoule. So if the answer is in kilojoule, I will write it as 2 only. What is P2V2? So this will be 1.1 into 9.1 minus 1 into 1. Now into 101.3 is the joules. Into 10 to the power of minus 3 is kilojoules. So if you will solve, this will come out to be 2.9 kilojoule per mole. Simple enough. So this is again a very good question. Now but you know it because I have done something similar. Okay. In this question, I am giving you a hint because it's a good question. Hint is find slope, and the equation of this graph is PV to the power of x is equal to constant. This is the hint. Because it is a rectangular hyperbola, something like that, so it is PV to the power of x is equal to constant. That will be the equation of this curve, the PV curve. So now I have given you a hint. Now understand one thing. Now in the last lecture as well as this lecture, we have covered the first law of thermodynamics. So when I say we have covered first law of thermodynamics, I have covered delta U, I have covered Q, I have covered delta W, and basically AK. No, D will not be the answer. No, D will not be the answer, AK. Listen to me carefully. Everything which I have derived so far, you have to understand those derivations. Only then the first law of thermodynamics will be in your pocket. Because if you derive everything, then there is no way you can get stuck at any point. But if you try to run random formulae, you will get stuck. So that is rule number 1. You have to derive everything after this class is finished. All of you promise me that you will go through the notes, you will take short notes of the derivations, and then you will write everything again. Only then it will be useful. Otherwise, if you are just going to remember the formulae, you will be stuck, because I will give you a question in which you will be stuck. Number 2, there are a lot of myths about this chapter, that it is very difficult. Ideally, it is not difficult. It is something which you have to understand properly. So, in case you have missed the last lecture of work, I would recommend that you go and see that recording as well. So now on the lighter note, how many of you are now comfortable somewhat with thermodynamics or are now able to revise it properly? It's not that difficult, right? Or is it? So if we are doing 9 questions, I think out of 9 questions, 5 or 6 questions, all of you are able to solve, right? So yes, 2-3 questions, obviously I will give you some difficult questions also. That is the job of a teacher. But if you are able to do 50-60% on your own, I think you are comfortable with that topic, because you are preparing for JEE, not boards. So obviously not every question will be comfortable. So PR says I am comfortable. Varsha, what about you? Heta, what about you? You guys are comfortable? So now in the next class, what we will do is, the next class is on Saturday 1 p.m. This class, the next class I'm talking about, we will be doing entropy. Now entropy is the most difficult topic according to a lot of students. It is one of the most dreaded topics for thermodynamics. I will make sure that it will not remain the same after the class is finished. So make sure that you attend all these lectures. Now, like the customary promise which we do to each other, quickly make a promise to me that you will revise the notes, you will do the DPP. and you will come prepared for the class. All of you, quickly make a promise and then we can disperse. We see you are very late, but hi, class is finished now. Fine, guys, quickly make a promise, say promise, and then we can go. Hetav, Solomon, Varsha, Ashish. Thank you. Okay, guys. Okay, best of luck to all of you. Let's meet again on Saturday. Till then, happy learning.